Alright, so let's take a look at this review sheet. It says determine all possible rational zeros using the RZT, or rational zero theorem. Then use the graph to find a zero of the given function and algebraically find all the factors and zeros of that function. So RZT, that's p's over q's. So we first need to look at our p's, which come from the back. So we have 1 and 12, 2 and 6, 3 and 4. Our q's come from the value in the front, which in this case there is none. Well, technically there's a 1 there, so the only factor for 1 is just 1. When we write our p's over q's, we put plus or minus, and then parentheses, we literally are just putting every p over every q. So that's 1 over 1, which is just 1, 2 over 1, which would just be 2, 3, 4, 6, and 12. Those would be all of our possible rational roots. And then for the work aspect of this, it says use a graph to find a zero of the given function. So you could open up Desmos or your graphing calculator and then just type in the equation. So we have x raised to the third power minus 2x squared minus 11x plus 12. And as you can see, we have a 0 right at -3. So then we're going to go -3 is what we're going to do synthetic division with. Close this Desmos real quick. Whoops. And then we would just do 1, -2, -11, and 12. Drop the 1. 1 times -3 gives us -3. -2 plus -3 is -5. -3 times -5 is +15. -11 and +15 is +4. -12, and then 0. Remember, it always goes remainder, constant x squared. So that's x squared minus 5x plus 4. So then our factored form, we can factor this into x minus 4, x minus 1. So we get x minus 4, x minus 1, and x plus 3. That plus 3 comes from that original -3 that we got at the beginning. So then what are the zeros? We have x is equal to 4, x is equal to, +1, and then x is equal to -3. Those would be the 3 zeros. All right. As for this second one, our p's are 1 and 8, 2 and 4. Q's again are just 1. So we have plus or minus 1, 2, 4, and 8. In this case, I know that -4 is going to work, so we put -4 here. Synthetic division, 1, 4, -3, -14, -8. I know that -4 works because I've looked at this graph previously. I've also already done this. So those are 2 ways I know that -4. If, say, come a test, I would literally tell you that if I was you, I would try -4 first. Or I would give you an image of the graph so that you could see that it crosses at -4. Anyway, drop the 1. 1 times -4 is going to be -4, so that's 0. -4 times 0 is still 0, so add those, and that's -3. Multiply again, you get 12, which would give you -2, which multiplied again gives you 8, which then gives you 0. Remainder, constant x squared, x cubed. So now we have x cubed minus 3x minus 2. So this is an unfortunate one. Does not factor at all. In this case where it doesn't factor at all, if this was a test, I would specifically give you another x value. So in this case, the other x value that I know works is 2. So then we need to do this again. So 1, 0, -3, -2. Drop the 1, you get 2. Add, which gives you 2. 2 times 2 is 4, which gives us +1. And then that gives us 2, which gives us 0. So this is x squared plus 2x plus 1, which would factor into x plus 1, x plus 1. So if we're writing this in factored form, we have that -4, so that's x plus 4. We also have +2, which is x minus 2. And then we have x plus 1 twice, so we can say x plus 1 squared. And that would be the factored form. The zeros in this case are -4, 2, and -1. If I was asking about multiplicities, this -1 would have a multiplicity of 2. All right, so that's P's over Q's. Next, let's take a look at number 2. Number 2 says, state the degree and write a polynomial equation in factored form and standard form, given the zeros of the function. So for this first one, we need to talk about what the degree is. Well, in order to know the degree, we need to know the number of zeros. We have x equals 4, which is a 0. We have x equals negative square root of 6, which is also a 0. The one that's not on here is x is equal to the square root of 6. Remember, all irrational roots come in pairs. So if you have the negative version, you also need the positive version. So the least degree of this function is 3. If we're writing it in factored form, we just need the factors. So what we're going to do is we're just going to resolve these for 0. So that's x minus 4. If we added that square root 6 to both sides, it would be x plus the square root of 6. And if you subtract the square root of 6 from both sides, that would be x minus the square root of 6. And that is a great factored form, okay? If you multiply these out and called that one the factored form, that's also great. But when you're trying to get it into standard form, what you need to do is you need to make sure you multiply the radicals, okay? Don't try to multiply the radicals with the 4, because that's when it's going to get a little dicey. So multiply the far right 2 here first. So that first value is going to give us x squared, negative square root x, positive square root x, and then negative square root 36. Or sorry, not square root x, square root of 6 multiplied by x. As you can see, the reason we multiply those first is because the middle term goes away. Square root of 36 then just becomes negative 6. We still have that x minus 4, so we need to multiply again. So x times x squared is x cubed. X squared times negative 4 is negative 4x squared. X times negative 6 is negative 6x. And negative 4 times negative 6 is positive 24. And then that would be in standard form. We have highest power first, decreasing power from there. All right. Taking a look at the next one. Just like irrational roots, imaginary roots also come in pairs, so we need to include x is equal to negative 5i as well. X equals 0 and x equals negative 2 don't necessarily need to come in pairs, so we wouldn't add anything to those ones. So least degree of this function is 1, 2, 3, 4, so fourth degree. Writing it in factored form, you have x plus 2, that's your negative 2. We have just an x, because that is the x equals 0. We also have x minus 5i, which would be the x equals positive 5i. And we have x plus 5i, which would be that x is equal to negative 5i. Just like the irrational roots, you should multiply these parentheses together first, the ones with the imaginary, because things will cancel. You could also just distribute this x in here. So we'd have x squared plus 2x. And then on this side, we would have x squared minus 5ix plus 5ix minus, and then when you multiply this last term together, it's going to be negative, and then 5 times 5 is 25. I times I is I squared. So again, middle terms cancel as expected, and we're left with x squared. What does negative 25i squared become? Well, that I squared is really negative 1. Okay, so then it's negative 25 times negative 1, so that's positive 25. On this left side, the x squared plus 2x stays, and now we can multiply this out. So x squared times x squared is x to the 4th. X squared times 25 is plus 25 x squared. 2x times x squared is positive 2x cubed, and then 2x times 25 is positive 50x. Just need to do some rearranging here, right? This 2x cubed and the 25x squared would need to switch spots just to make sure we're in standard form. But other than that, that would be our answer. All right. So that is page 1. This is literally 4.6 and 4.7. Okay, that's a huge part of it. All right, I will pause this video, and then the next video will be page 2.